There is nothing much difference between the statistics and probability. The main difference between the statistics and probability based on the existed data set. It will say there is the chance to be ideal world will behaves like this in our future. Statistics analyzes our world is like this in this particular time period. For example, last 1 month, like present day. Present day. Statistics analysis the past events till present day. Probability will try to predict likelihood of the future event from tomorrow onwards. That's the main difference between the probability and statistics. If we want to predict future event by using probability, we need to analyze our past events by using the statistics. That is the relation between these two things. Okay.
Yes.
See, yeah. If we want to find probability, we need the two types of information. One is the what are the set of all possible outcomes. Another one is the what we want to find particularly. For example, let's throw a toss by using coin. Okay, what is the possible total outcome? Two. One is the head, other one is the tail. There is a possibility to be drop an a head or tail. That is the total outcomes, total possible outcomes. If we want to calculate the probability to be a head, what's that? So out of the all possible outcomes, what are the how many possible outcomes are related to the head? One. So
One.
one will place what is the possible outcomes of particularly what we want in the numerator, will place all possible outcomes in denominator to calculate the probability. So let's take example for the two coin tosses to set of all possible outcomes. If we throw we passes two coins, there is the four different types of possible outcomes. Those are two heads, or first coin head, second coin tail, or first coin tail, second coin head. There may be chance two coins will give the tails. So these are the total outcomes. So four is the will place in denominator. If we want to predict probability of the to become two coins head, that means how many possibilities are there? There is only one possibility. There is only one possibility to come to give two coins heads. That is the 1 by 4. That means 0.25. What is the probability to be two heads, two giving the probability for to get the two coins tails or head, that is the 1 by 4. 0.25, 0.5. Why? Because there is a one chance to be two coins will give heads or two coins will give tails. If we want to calculate probability for the one head, one tail, there is the two chances. There is a chance to be first coin is the head, second coin is the tail. There is the another chance also. First coin is tail, other coin is head. So 2 by 4. That means 1 by 2. So the probability to be a one is head, one is tail is 0.50. Okay. We will
Yes.
calculate probabilities like this. This is the concept. We have the some rules for the probability. For example, if we want to calculate the probability of A and B, so it it needs to be consider A and B both. That is the probability of A multiplication probability of B. But if we want to use these formula, there is one rule, that is the independent events. That is the outcome of the B event is not dependent on the outcome of the event A. For example, let's take the example of the same two coins. I throw one coin, it gives the head. If I want to throw another coin, is this head, whenever I throw first coin, it gives the head. Is it uh, impact the whenever I throw the second coin, it be a head or it be a tail? Or second coin,
No.
whenever, yeah. So it is the purely independent. The whenever we throw coins, whether it is the head or tail, is the independent. It won't depend on the previous task. So if is there any two independent events happens, then only this probability of A and B equal probability of A multiplication probability of B, we
Apply.
can use this formula. For example, if the probability of getting an easy call is 0.7, if we want to so many you people know, some bank employees will call us, ma'am, you have the offer for the personal loan, you have the 10 lakhs offer, 20 lakhs offer, you have the documentation free personal loan access offer, like this. So some people, whenever they lift call, they will, if they have any requirement, loan requirement, they will accept that one, they will take very easily. But some people, if they don't have requirement, but these people work is to providing loan for the others to favor the bank. That's why these people take complex calls. These people, it takes some complex tasks to convince the others. Okay, that is the two scenarios. So whenever we call 10, we do 10 calls, the probability of getting easy call is the 0.7. What is the probability that the next three calls will be easy? Next three calls will be easy. That means probability of easy 1 and probability of easy 2 and probability of easy 3. Okay. Probability of easy 3. For example, let's take I got the easy call in with probability of 0.7. Is this next call will be easy or hard? Is it depends on the previous call?
No.
No. Why? Because that customer previous we called for the one customer, now we call for the other customer. How he behaves, it's not depends on the previous customer. So these are the
Yes.
independent. So directly we can use this formula, probability of A and B equal probability of A and probability of B. So I applied same formula. So the probability of 2B is next calls will be easy. That is the 0.343. Okay, so based on the mm, independent events and independent events, we'll do like this. Probability question. We'll ask one question. Are you able to understand this one till now?
Yes, ma'am.
Yeah. A basketball team is down by 2 points with only a few seconds remaining in the game. Given that, actually there is some tournament running. That is the basketball team. They need 2 points to win. Those are the last few minutes, few seconds. So there is a three types of chances they have. Chance of marking 2 points should to tie the game, 50%. If they want to gain 2 points to tie the game, if this team gain 2 points, so it is equal to the other team. So there
Yeah.
might be tie. So for this chance, it have the 50%. Chance of winning in overtime, 50%. Whenever game over to the game ties, they will give some more few seconds. So they give chance for the two teams, one ball chance for the two teams. There is also 50% chance, either team one will win, either other team will win. So the probability of to win is the 50%. To gain 2 points, it's 50%. Then after um in overtime, to win the game, it takes the 50%. Chance of making 3 point. If they are able to gain 3 points without any overtime, without any time, they will win the game with 30% probability. Okay. These are the probabilities. Now you can say, what should the coach do? Go for 2 point or 3 point shot. In this situation, these are the probabilities. Which chance will the coach will select, whether the 2 point or 3 point? If he go for the 2 point, he need to play other game and in overtime to win the game. If he go through the 3 point, he is able to win with 30% probability. People, please think and answer to the question.
Mm, uh, maybe ma'am, you should go for 2 point.
Okay,
Two
it's
point.
your answer.
Yes.
What about others? Lakshmi and Maruti, Muhammad Ali. If you feel you are the coach, will you go for the 2 point shot or 3 point shot?
2 point shot, ma'am.
Okay. Why 2 point shot? Why not a 3 point shot?
Well, as
Okay.
per yes, ma'am. So as per means assumption means as we can see here, only few seconds are left, and we need 2 points to tie up first of all.
Hmm.
So as a coach, means the winning chances means 3 point shot. I think will be rarely because with respect to time. But if we go for 2 point shot, then there is a chances that we can get a tie.
Okay, okay.
And
Akash, it's not like that. You think in probability way. They provided some probability values. Based on the probability, we'll take the decision. So you can think on the based on the probability.
okay, so probability of 2 point shot is here is I think 1/2, right?
They already
One,
gave given 50%. 1/2 means 50%.
yeah,
50%. Okay, we'll explain. We'll explain. Let's take.
yeah,
If he has taken 3 point, they directly given the 30%. That means 0.3% probability. It's clear cut. Coming to the 2 point. For example, if he has chosen 2 point, there is a chance to get 2 point. That is the 50%. That is the 0.5. If he gain 2 points here, is he win the game? No. He need to play other game, that is the by taking overtime. So in there also, is this overtime? If we in this overtime, if the game what how many points they are scored, is it depends on the previous 2 points?
no,
No. These two are the independent. So here also in overtime he have the 0.5% probability. If he wants to win this match, he need to gain these two. He need to make a 2 point shot in first, and he need to make a win here also. So based on this formula, what is the probability? So probability of 2 point shot and probability of in overtime. So 0.5 multiplication
in
0.5. Total
0.5, yeah,
probability is
one by
0.25.
25,
Yeah.
yeah,
Here, chance of making 3 point shot to win the game is 0.30. So,
yes,
the probability of 3 point shot is 5 points more than the probability of 2 point shot.
okay,
Yeah. So, he will choose 3 point shot.
okay, okay.
Yeah. And not only he, you can think how many seconds to gain the 2 points, to gain the 1 point, to gain the any number of points. You need to shot, you need to throw basketball within the same seconds. So you won't, if let's example, let's assume if you have that 2 seconds to throw the ball, if the people gives 4 seconds, will you able to throw directly to the 4 points based on the time? If
No,
they give 1 hour time, are you able to throw ball uh, for the final shot?
not sure. Means
Not
I
sure.
don't. Yeah,
How much time he there is not that is just a mental pressure. How much
yeah.
time we have, that is the related to the mental pressure. If we want to play game within the time, we will do whether it is the 1 point, 2 point, 3 point. That's not the matter. We need to throw ball to gain the 1 point, 2 point, 3 point. The player who are playing, without giving chance to other team how fastly he is throwing. That's the matter comes under any game. But chances, if he have taken first 2 point chance, they need to play with them another time by taking overtime. If they try hardly to gain 3 points, definitely they will win without giving any chance to other team.
Yeah.
That's why this 3 point gives the 5%,
Means high
0.05% high probability.
high probability. Okay.
Yes, that's this is the how we are calculating probabilities. Lakshmi and Maruti, is this clear?
Yes, ma'am.
Yeah. So whenever we are in confusion, these probabilities will help to choose the correct chance. Types of probabilities. So we'll go through the problem. See, here I explained about the probability rules. Um, you are able to the concept. Whenever we play with the game, then we'll understand how to probabilities use, how to use probability technique in the real time. That's why I have I'm go through the one problem, okay, just for
Yeah.
easy of understanding. Uh, this is the bank loan default. For example, let's say loan default no means these people are not eligible to take loan, okay. Yes means these people are eligible to take loan. Based on the age also they differentiated. These many young people not eligible to take loan. These many young people eligible to take loan. Okay, like this.
Okay.
They give the some values. So I calculated totals also. If we want to, um, what is the probability of no? If we want to calculate probability of no, we need to know about the who are the total number of people. This one,
Yeah.
okay. Who are not able to take loan, who are not eligible to take loan, that people are this one. This is a numerator. What is in denominator? Total possible outcomes. That means the people who are applied for the loan, the people, whole people who are eligible and who are not eligible. That is the 46,687. So 38,130 by 46,687 is the 0.816. Okay.
Okay.
Like
Yeah.
that, probability of yes. Probability of yes means the people who are eligible for the loan. This is whether it is young age, middle age, old age, it's not a matter. The people, why? Because here we are considering only probability of yes, nothing. Probability of yes. That means the people who are eligible for the loan. 8557 by 46,687. These people are whole people who applied for the loan. That is the 0.184. So total is the 1.
So
Same
ma'am,
like
numerator will be in the yes format. In the numerator will be 8,557 and the denominator will be 3,586.
3586, not 35, 46687. These are the total number of people. For example, 38,130 people are not eligible for the loan. 8,557 people are the eligible for the loan.
Eligible. Yeah.
Yes. So these are the total number of people who applied for the loan. That is the 46,687.
Okay.
If we want to calculate probability for yes, that is the who are people eligible for the loan, 8,557 by total number of people, that is the 46,687. In denominator,
Okay.
we'll place the total possible outcomes. How many possible outcomes are there? We'll give that number in denominator.
Okay.
Yeah. For example, let's take the same one. If we have the coin, whenever we throw coin, there are the what is the total possible outcomes? Two, whether it is the head or tail. So we give it in the denominator. If we want to calculate the probability of a head, how many heads will be present whenever we call one head? So probability of head is 1 by 2. If we want to calculate probability of a type, that is the also 1 by 2.
1 by 2.
2. Let's take the two coins. Whenever we throw two coins, what are the total possible outcomes? H, H, 1, H
4.
tails.
Yeah.
Tails are H. Two tails. So total possibility of outcomes 4.
4.
Yeah. Out of those four, what is the, if we want to calculate what is the probability of tail, one is tail, one is head. How many possibilities? Two.
One.
Maybe either first coin head, second coin tail, or first coin tail, second coin head. So two possibilities. So 2 by total
4.
outcomes 4. So here also the people who are applied for the loan, all people is the denominator. Those are the all possible outcomes. Out of those, we need to calculate the probability of the who will get the, how many people will get loan. That is the 8,557 by 46,687. Okay.
Okay.
Yeah. If we want to calculate the probability of young people who are applied, how many what is the probability to apply for the bank loan who are engaged, who, that is the, how many engaged people applied for the loan? Sorry, 14,089. What are the total people who applied? That is the 46,687. In this, who are applied for the loan, these 46,687, 14,089 people are engaged people. So, how do we calculate for the probability of engaged? These 14,089 by 46,687. That is the 0.32. Yes, probability of middle age is the 32,219 by total number of people applied 46,687. That is the 0.690. Old age is the 379 by 46,687. That is the 0.008.
Okay.
Okay. So you can calculate any probability. This is the probability of the people who are not eligible for the loan and they are engaged people. That is the 10,503. 10,503. What are the total number? Total number is always 46,687. How many people applied for the loan? So this is the probability of 0.25. Like this, I calculated probability for the all values. This one. Okay.
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 Yeah.
Uh, Now, are you able to understand how to calculate probability?
Yes, ma'am.
Yeah. So, after calculating this, how do we answer for the questions? We'll check here. There are the different types of probabilities. Marginal probability. Marginal probability means describing a single attribute. Whether, for example, let's take what is the probability of no? What is the probability of no? 0.816. What is the probability of middle aged? That is the 0.690. So here, for example, whenever we calculating the probability of middle aged, we won't consider whether he is eligible for the loan or he is not eligible for the loan. Just whether he is middle aged or not. Here we are considering single attribute. Okay, that is the, for example, probability of middle aged is the 0.690. Here also, in probability of no, that is the 0.816. These are the people who, the probability for the people who are not eligible for the loan. We won't consider whether he is engaged, whether he is middle aged, whether he is the old. We won't consider anything. Just we'll consider only one single attribute, that is the people who are not eligible for the loan. Probability of no means. Probability of yes means probability of people who are eligible for the loan. That is the 0.186. What if we can describing about the single attribute, that is the what, which type of probability? Marginal probability. Okay.
Okay.
Don't worry.
Yeah.
Just you can know about the what is marginal probability. How do we, for example, let's take if we have the spam mail, we we have the spam mails. Out of the, for example, I got the 200 spam mails. Out of the 200 spam mails, I did not observe any free free word in the spam mails. In out of the 250, what is the probability whenever new mail comes, what is the probability whether it having the free word? Okay, previously out of the 200 I have the 50 mails are with the word free. Okay,
Okay.
so what is the probability of the word which is free? Whenever new mail comes, what is the probability to be this mail is having the word free? What is total mails are 200, how many mails does have the free? 50. So 50 by 200, that means 1 by
Yeah.
4, so
One by
0.25.
yes.
0.25 is the probability, like that. So okay, we'll go through the problem. Are you able to understand what is the marginal probability?
Yes, ma'am. Yes.
Probability describing the single attribute.
Single
Joint
attribute.
probability means, yeah, joint probability means probability describing the combination of attributes. So here we'll consider, for example, which type of questions means I have the one pot. In that pot, I placed three blue balls, three red balls, three green balls, nine balls, three blue, red, green. Whenever I take three balls from the pot, two balls will be red, one will be green. What is the probability to take two balls are the red, one ball is the green? Hmm? For example, if we want to calculate probability to take one red ball, that is the total number of balls are the 9. So we want to total number of red balls. So how many red balls are there in the pot? 3.
Oh,
So
okay.
we want to pick one red ball. That is the 1 by 3. 1 by 3. So
Three.
that is the marginal probability. But this time I want to take one red ball, one green ball. So combination of red and green. It must should be one red ball, one green ball. Won't be two are red balls, two are green balls. So what we consider? How many balls are there in the basket? Total balls are 9.
Nine.
Yes. What is the first? In that we need to calculate the what is the probability for the to bring one red ball from the out of the red balls, to bring the one green ball out of the green balls. Then after we need to calculate the what is the probability for the one red ball, one green ball out of the total 9 balls. That is the combination. Here same thing we did. What is the probability of yes and no? That means the probability whenever new application comes, what is the probability is that application related to the yes as well as the no. That is the combination. That is the 0.077. This is the probability of yes and no.
Okay.
Okay. So this application is related to the he is eligible to the loan and he is engaged guy. We should need to satisfy two conditions. He must be engaged, he must be eligible for the loan. That type of probabilities are joint probabilities. Okay.
Okay.
Union probability. Union probability means will do you know people if condition?
Yes, ma'am.
Yeah. In if condition, if we write and operation for the two conditions, that must satisfy the two conditions. If
Yes.
we give our condition, there might be chance whether it is our other one. For example, see
Yeah.
probability of yes are young. That means the probability of yes are young, not be both,
Hmm.
not be both, whether it is
Both.
yes or young. That is, for example, how do we get whether he is, for example, whenever new application comes, he must be eligible for the loan. He doesn't have the engage. If he is engaged guy, he is not eligible for the loan. That is the condition here. P, yes or young. Either one condition, not both conditions. Okay. At that
Okay.
time, what we will do? First, we'll calculate the probability yes, probability young. Then after we'll add these two. Out of these two, we will subtract the probability of both combinations yes and young. Then we'll get the condition yes or young, whether he is related to the yes or whether he is related to the young. That's it. That is the probability of yes is the 0.184, probability of young is the 0.372 minus
Okay.
probability of yes and young. That is the 0.409. Is this
Okay.
problem are you able to understand this one?
So, first of all, we have to add both marginal probability and we have to subtract with the joint probability.
Hmm.
Then we will get the OR condition, right?
Yes. Uh,
Ma'am, one thing I wanted to know that this joint probability we have calculated here, yes and young for the 0.077.
hmm.
So, how it came actually, ma'am? 0.077
Yeah. This is
for
the
the joint
probability.
probability.
This is the sorry. What's your question? This is the probability to be a new applicant to be he is eligible for the loan and he is engaged.
Yes,
If you want, yeah. If you want, we'll say other thing.
but ma'am, one thing uh, means he is young and yes, the both when we are calculating, we will get two values. Then we have to combine the two values in the one value so that we can get a particular one value. So means how we will merge the two both the values in the single value.
Yeah, we'll do. Uh, First, we'll explain about the differentiate what is joint probability, what is union probability. Let's take in this diagram. This is the event A. This is the event B. Okay.
Okay.
If we want to calculate joint probability, we'll take this is the session, this middle one, which are having the both events A and B.
Yeah.
This is the joint probability. Coming to the union probability, that is the this one here and this one. Here we won't consider this part in union probability. That's why in
Okay.
union probability we calculate the probability of A, that is the probability of S, and probability of B, that is the probability of young. Then after we'll subtracted the probability of A and B here. This one. So this part and this part is the union probability. Here is it clear which is union probability, which is joint probability?
Yes, ma'am.
Yeah.
The middle one is the joint probability, and when we add A and B, and then we'll subtract means the middle one, it will be union probability.
Yes.
Okay.
Coming to the your question is the joint related to the joint probability. Probability of yes young. For example, let's take the same example coins. Whenever we throw two coins, what is the probability of the one head one tail? So in that means for if we throw first coin, there is a chance to be it is the head, other coin is the tail. That is the one chance.
Yeah.
Other chance is the probability of first coin is the tail, second coin is the head. So two chances. So
Yeah.
what is the total chances? Two. How many
Two,
outcomes do we have? Four.
four.
Whether both are head, both are tails, one head, one tail, one tail, one head. So 2 by 4. We calculate the probability of tail and head is the 2 by 4. Same
Yeah.
thing will apply here. For example, let's take these are the total number of people who applied for the loan. So this is the total possible outcomes we'll place in denominator 46,687. Is this clear?
Yes, ma'am.
Yeah. If we want to calculate the probability of yes and ing, that is the joint probability. So if we want to calculate yes and ing, what we'll see? We'll
Okay.
take, we'll check all application. Out of those all application, we'll separate the application which is eligible for the yes and who is ing, who will satisfy both conditions, whether he is ing and as well as he is eligible for the loan. We'll separate those applications. How many applications does those? 3586. Okay.
Yeah.
Out of total outcomes, these are the some outcomes which are satisfy our condition. If we want to calculate the probability, what we will do? These are the definitely chances to be satisfied the conditions by denominator 46,687 total possible outcomes. That is
Okay.
the value 0.077.
Yeah. Got it.
Yeah. For example, this is the joint probability. Let's take the other probability, union probability. Okay.
Okay.
In probability condition, same denominator always same. Total number of possible outcomes. That is the 46,687. Coming to the numerator, it needs to satisfy only one condition, whether he is engaged, other whether he is eligible for the loan. Is it okay? So,
Mm.
see, these are the total number of engagers, but out of these 14,000, some people, 3,586 people will eligible for the yes. But we need to satisfy only one condition, whether it is young or yes. That's why what we do, we'll take these 10,503 who will separate. First we'll take these 10,508 503 people, then after we'll take these 4,851 and 120 people. Why? Because these are the people who are eligible for the loan but not engaged. This is the people who are eligible for, who are engaged but not eligible for the yes. We'll add these four values to calculate the with probability of yes or ing. Yes or ing. So we'll take these three values. So 10,503 plus 4,851 plus 120 by 46,687. So that
Okay.
is the union probability. Instead of, but if they did not provided these values, if we have these values, we'll calculate probability like this. Okay. If
Yeah.
they did not provided values like this, instead of this, they provided probabilities like this. What we'll do? We'll apply formulas like this. For example, let's take, if you want, you can check. This is the probability we got by using this formula 0.409. Okay, you can
Yes.
cross check.
Yes.
So previously, which type of which we calculated this 0.225, 0.149, 0.003. You can add these three probabilities. It must be this one. If you want, we'll open calculator. Let's check what will happen. 0.225 plus this one, who are yes but not engaged, 0.104. 0.104 plus this, who are yes but not engaged, 0.003. 0.332. What we missed here? This is the people who are engaged, not yes. Yeah. Here we are subtracting two times. Let's take. Actually, here we are, you can add this one for the 0.077, 0.409. That means what
Mm.
we did previously is we are not here we are subtracted P of S and N one time. So if we want to calculate P of S and N, it this side it is the subtraction. If it comes this side, what will happen? It become
Yes.
as a
We'll
plus
add.
value. Yes,
Yeah.
plus value. That is the 0.409. So here we are subtracting two. We are not considering this value. That's why we got the same value. Uh, just a minute, I confused you people. So this is the one thing. Are you able? These two values are same. Okay. So by adding these values here, actually
Yes.
it comes under young under S. So we need to add this one two times, but we need to add one thing only, whether it is young or S, one condition. That's why I added this thing. Instead of two times, I added only one time. So we get the same value. If you can use this formula, you will get the 0.49. If you calculate through this, it gives the same value. So instead of doing these many calculations, these people provided this formula to us. Okay.
Yes.
Actually, we need to add this 0.077 for young and S, both in both scenarios. But we don't want to combine S and young. That's why I added these 0.077 is one time. That is one time, maybe it is related to this and whether it is related to the young. Okay.
Yes.
Yeah. If you have any doubt, you can ask. People, are you able to understand what is marginal probability, joint probability, union probability?
Yes.
Yes,
Yeah.
ma'am.
Yeah. Coming to the conditional probability. These are the simple combinations. It is the conditional probability. This probability we frequently uses in our models, naive Bayes models like this. For example, probability of A occurring given that B has occurred. Here we need to uh, occur young and S at a time. But here related to the joint probability, the probability of A occurring given that B has occurred. The sample
Okay.
space is restricted to this single row or column. This makes rest of sample space irrelevant. Rest of the, for example, don't worry, I have one problem for the conditional probability also. For example, what is the probability that a person will not default on the loan payment given she is middle aged? Did you understand question? Will read again. What is the probability that person will not default on the loan? That means will not default on this. So he is not eligible for the loan payment
Yeah.
given she is middle aged. That means out of out of the whole middle aged people, what is the probability that a person is not default on the loan? That means this is the total outcomes he gave to us. Total outcomes means they are middle-aged people. Out of the middle-aged people, what is the probability to be a default loan is the no. That is the he is not she is not eligible for the loan. That is the probability of no by middle-aged. Till now, we have taken total possible outcomes in denominator.
Yeah.
Yes. Yeah. Here, in conditional probability, they need to add some more conditions to the while calculating probability. Here, what is the condition? I am considering only middle-aged people. Out of the middle-aged people, what is the probability to be a no? That means to be the people who applied for the loan is not eligible for the loan. That
Okay.
is the this is the total outcome, total probability for the middle-aged people. This is the out of this is the probability to be a no. That is
No.
the 0.586 by 0.690, 0.85. So based on the which type of probability we are calculating, we need to select the values. Okay. For
Okay.
example, let's take what is the probability for youngest out if the given is the yes. If the given is yes, that is the probability of young by yes. Young by yes.
Okay.
That means what will we take in denominator? Here denominator is the yes. That is the probability of
Zero
yes.
point.
Total probability
Yeah.
of yes. This is the 0.184. Okay.
Okay.
0.184 is the total probability of yes. Out of
Yes.
this, what is the whether she is engaged? That is the
E to the
0.077.
7.
So 0.077 by 0.184.
Okay.
Okay, we'll count. Let's take probability of A and B is the probability of A and B by probability of B. That's what happening. See, what is this 0.586? That is the probability of no and middle aged, right?
Yes.
Probability of no and middle aged is the 0.586.
I get
What is
6.
this 0.690? That is the probability of middle aged
Of
only.
middle aged.
Middle age, that is the probability of middle aged. That's
Middle
the same thing I've written here as a formula. This 0.586 is the probability of A and B by probability of B. Sorry, here I did not place this one. Probability of A by B is equal probability of A and B by probability of B. Same probability of middle aged by no. That means we'll take the total. No is the 0.816. Out of this
816.
0.816, what is the probability of middle aged? That is the 0.586 by
586.
0.816. That is the 0.72.
7.
So from this one, probability of A by B is equal probability of A and B by probability of B. From this, we'll get the joint probability formula, that is the P of A and B is equal P of A by B into P of B, probability of B, right?
Okay.
Here it is in division condition, in division format. So if we we change from this right hand side to left hand side, what will happen? Here division converts into the multiplication.
Yes.
Okay, that's what happening. Probability of A and B, we we changed position of the probability right hand side to the left hand side. Now it becomes the division format to the multiplication format. Okay, that is
Okay.
the same thing. uh, just I rewrited this one like this one. That's it. Is it okay, Lakshmi or
Yes, ma'am.
Marti? Yes. I hope you people are able to understand Bodmer's rule
Yes.
in
Yes.
mathematics. Yes. So let's take this is the this one. I- By using this formula, I write it some other formula, probability of B by A. So here probability of A by B is the probability of A and B. Same like probability of B by A is the probability of B and A and B. So probability of B and A and B value is the same. Here the denominator will comes to the probability of denominator here also. So probability of A is presented in denominator. That's why I placed the probability of A here.
Okay.
Okay. So how I converted I changed right hand side to the left hand side. Same formula I applied, probability of A and B equal to probability of A into probability of B by A.
Yeah.
So just I rewrited this formula like this, B by A. Here A by B, here B by A. So due to these two equations, probability of A and B is equal, probability of A and B is equal these two, right?
Yeah.
So these two are probability of A and B. So if if we have the two equations which left hand sides are both the equations left hand side is equal, that means right hand side also equal. If x is equal 5, y is equal 5. So the right hand side x value in x is equal 5 equation, y equal 5 equation, both 5's are equal. That means x equal y. Is it right?
Yes.
X is equal 5. That is the first equation. Y is equal 5. This is the second equation. In both equations, right hand side phi value is the equal. That means left hand side x equal to y. This is the condition. So this is the satisfiable condition. If x is equal to 5, y is equal to 5, that means x is equal to y. Same formula I am applying here. P of A and B is equal to this one. P of A and B is equal to this way. That's why I equated these two equations here. P of A by B into P of B is equal P of A into P of B by A. Okay.
Okay.
From these two equations, I regenerated another formula, that is the P of A by B is equal probability of A into probability of B by A by probability of B. Okay, this is the
Yeah.
conditional probability how we derive through this condition.
Okay.
Don't worry, you don't need to remember these derivations. Just why I if I gave this formula directly to you, it won't be every time you need to think about the how did I get this formula, how did I get this formula from the probabilities. That's why I explained these derivations. Okay,
Yeah.
this is the conditional probability we will use while building the models. And you don't need to remember these. Actually, you just remember this concept. You don't need to apply it. You don't need to calculate each and every probability. You don't need to calculate to apply same values here to build the model. Everything will be available on Python packages. Okay,
Okay.
just if you people know the um, concept, then you are able to select for example, let's you are able to select, for example, whenever case scenario you have seen, whether it is related to the joint probability, you will go through the one way. Whether it is related to the conditional probability, you will go through the other way. First you need to find whether it is related to the which type of probability. See,
Yeah.
here, whenever I read this case, you are not able to find what is the exactly which type of probability they want to calculate. See, what is the probability that a person will not default on the loan, will not default on the loan payment given she is middle aged. You need to find what is the total outcomes, whether it is the middle aged or whether it is the default will not default on the loan. So the understanding part, how do you analyzing
First of all, we have
to
to.
analyze this one? It's easy to apply if you know the, if you are able to understand, you want he is asking about the probability of no by middle age, then it's easy to substitute values. If you are not able to understand this problem, if you know the entire concepts and formula, but you are not able to find the solution, understanding is the first thing in conditional probability. Okay,
Yes.
did you understand how to calculate the conditional probability? How do we get this formula?
Is there any indication that in the problem statement that okay, this has been given, then we have to use the conditional probability, or okay, this has given, then we have to go with joint probability. Is there any means
No,
indication?
no, we need to understand problem correctly, that's it.
Okay.
By seeing given, by seeing some other by based on the words, we can't go with the whether it is joint probability or whether it is conditional probability.
Mm-hmm.
That's why I'm explaining these concepts through the problem. See, let's take, if I did not explain through this problem, if I explain directly joint probability through the what is the diagram I showed you, definitely it's very hard to identify the problem. That's why I'm explaining through the problem. The probability describing the combination, that is the probability of S and Young. Probability of S or Young. Here I have actually, instead of taking probability of S or Young like this, I given the one problem. What is the probability that a person will not default on the loan payment in a given she is middle aged? Don't worry, Akash will provide some tasks for this session. Why? Because this is related to the central tendency probabilities. These are main tasks. We'll provide some questions on this. You people try to solve those questions. While solving those, here I am explaining everything clearly, so you won't get any doubts. While solving those problems, you will get some doubts. So based through that doubts, you will learn some more thing. If you have any doubts, you can ask. We'll clear. We'll say how to solve that one, how to think while solving the problems, everything.
Yeah.
Yeah. So like here I explained one problem. Like this, we'll give another problem to calculate the conditional everything. We'll provide some these type of questions also. You people can understand those questions. You can solve while understanding those questions, while solving those problems. If you have any doubts, you can ping me through WhatsApp, through me, Teams.
Yeah, sure.
Yeah. So conditional probability Bayes theorem will use the conditional probability. Okay. Actually, we have that uh, logistic regression. We have the two types of regression. One is the models. One is the regression models. Another one is the logistic models. If we want, sorry, classification models. If we want to build um, classification model, this naive Bayes theorem will be useful. For example, if we have the lot of files which are related to the different subjects, if we want to predict, we have the information about the this file is related to the this subject, this file is related to the this subject, like this. We have the 1,000 files. We have the outcome, that is the output. That means that file related to the which subject, the type of information also we have. By using that information, we'll build one model. Whenever new file comes, based on the this one, this probability, Bayes theorem uses this probability. What is the probability to be this file is related to the this subject? It will calculate the probability. For example, if we have the total number of files 4,000, out of the 4,000, if we have the 1,000 files are related to the maths, so what it do, what is the probability to be this file is the maths? What is the probability to be this file is the science? What is the probability to be this file is the some other? Based on the probability, which subject have the high probability, then this file is related to the this subject. It says like this. Okay. Don't, by using
Yeah.
this concept Bayes theorem, build the model.
Okay.
Okay. In time series also, we'll calculate the what is the probability for the future events based on the existing data.
Okay.
Don't worry, whenever we get those models, concepts, we'll explain.
Okay, ma'am.
So, ma'am, in this right now, when means in the real time, when means people are working, then some of the use cases of the conditional probability, what should be means in the real time examples we can say, means how we will be using conditional probability. Do we have any example?
Yeah, if we want to filter mails, whether it is a spam or non-spam.
Okay.
Yeah, for example, we have the spam mails and non-spam mails total. We have the 40,000 spam mails, 30,000 non-spam mails. We have that information. Each mail with whether it is a spam or non-spam. Whenever new mail comes, the people, we don't want to open all spam mails. Why? Because those are the useless mails. That's
Yes,
why
yes.
the who are in management position, what they do, they need to filter whenever new mail comes, whether it is the find whether it is the spam or non-spam. If it is spam, it will throw these mails to the others. If it is non-spam, it is comes under the primary mails. So in that situation, this conditional probability will be useful.
Okay. Ma'am,
Yeah.
can I use this model or this means building this model for my Gmail in the personal level? Can I build it? Is
Yeah,
there a possibility, or means I
you
have
can
to
able to build
know?
model, but how do you integrate that model into the your personal mail?
Yes,
Gmail,
that is.
yeah, will
Yeah.
using Gmail account, they have some rules. They will provide services to us as a Gmail services. But if they allow to integrating your model into their service, then it's possible.
Okay.
That if, for example, Outlook, let's take the Outlook. Outlook means our company will
Yeah, yeah.
take the services, they will purchase those Outlook services. While
Yes.
purchasing, they will say they are paying something to them. So they will ask, we need this type of services, this type of services, and they will take some permissions to integrating some features which are useful to them. They will take permissions. Based on that, they will integrate these models to the that. If you have that type of permissions integrations, you can do. It's possible.
Okay.
Yeah.
And ma'am, if we want to create any personal project, if in the scenario which we do not want anyone's permission or anything, so can we do any project based on this conditional probability or something in the
Model
personal
will,
level?
yeah, definitely. Akash, today probability class finished. In next
Okay.
session, I think definitely linear regression model.
Okay.
After conditional probability is definitely linear regression model. So at that time, we'll explain how to get data, how to reprocess the data, how to analyze the data, how to build model.
Okay.
Yes, after conditional, that is the linear regression. Yes, next session is the linear regression model. So then you will understand how to. Then after one from whenever model starts, we'll take 2 sessions per week. One session for the this one to explain the concept behind that model. Another session Jupyter notebook, how to build that model using the Jupyter notebook. That is the Python language.
Okay.
Okay. So
Okay.
then you
Yeah.
will understand how to use these concepts while building the model.
Okay.
Okay.
Yes,
Actually,
ma'am.
while building model, you don't need to remember these many formulas. You don't need to calculate everything.
Mhm.
Do you think is it possible to calculate everything through the computer? If we want to calculate through the computer by applying, by writing formulas, by applying, by substituting values, it, we won't do everything. Everything will be done by the implementation time. These C language, Python language, these people already implemented those functions in their packages. Just we
O-
need to install those packages directly. If we have the
Okay.
one package to if we provide the information about the data, not only data points. Data means previously I gave 1146 is the data set. So I calculated MAD, mean absolute distance. What
Yes.
is sigma of x minus mu by n? That is the sigma of 1 minus what is the mean? Mu means 3 by 4. So to do everything, we don't need to. That is the concept. If we want to perform that mean absolute distance, there is one package that is the sklearn. From that sklearn, we'll import directly MAD library. If
Okay.
whenever you give 1146, the data points to that function, automatically it calculate everything. It gives the final output. This is 0.75, 0.85. This is the mean absolute distance for this data set.
Okay.
Same thing here, we'll provide data whenever we uh, whenever whenever we provide data, there is the one library that is the base regression library and base classification library. After down importing that base classification library, will provide the data directly to that library. It automatically builds model. It gives the some weights. By using that weights, will whenever new input comes, will predict whether it is related to the spam or non-spam. So next session you will get some idea how to build models, how to do everything.
Okay.
At the time we'll explain also. Actually, to building model, it's not a matter. To building good model is the matter. If whenever who doesn't have any data science knowledge, if they will ask Google like this, how to build linear regression model in Python, you can go for the any web. It gives the like this. It gives the some data how to. It takes the this is the data x and y. Then after it it calculate the estimated coefficients like this multilinear. They will provide code like this. Then after they will provide some results. See, multilinear polynomial. They will provide the code also. But what's the use? Whenever come to the real scenario, it gives the 30% accuracy or 40-50% accuracy. But the client, what he is expecting 85 to 90% accuracy. If we want, by using same data, if we want to improve our model accuracy, we need to know about these concepts. Okay. If we
Okay.
know these concepts, then only we'll modify our data to build a to giving the to improve the accuracy.
Okay.
Okay. So based on the model accuracy, how to we change data, how which type of concept we need to apply on data before going to the to build the model. That is the main thing we need to know. If we know that those concepts, then only we are able to build good models.
Good models. Okay, with good
Yeah.
accuracy.
Yes.
Okay.
If you have any doubts regarding probability, you can let me.
Yeah, ma'am, it's fine.
Yeah. Mm.
Agree.